Hi guys, in this lesson we look at how to factor by grouping. So if we look at expanding two binomials using the distributive property, and we have a plus b times x plus y, well, we can expand this by distributing x plus y into the brackets a plus b, and we'd get a times x plus y plus b times x plus y. That's using the distributive property. And notice that here, when I do that, I actually have a common factor of x plus y between a and b. So using the symmetric property of equality, if I have something in this form, where I have a times x plus y plus b times x plus y, and x plus y is actually a common factor, and then I can use the symmetric property of equality to rewrite something in this form in the form that we have on the left side here, in factored form. So something to look out for is if you have four terms, or sometimes more terms than three, really, you should be looking to employ a grouping strategy. If you have something of the form a times x plus a times y plus bx plus by, a good strategy to try to implement is a grouping strategy to see if I can rewrite the terms in this form and see if there's a common factor that's a binomial or sometimes even a trinomial that you can then common factor and write as a product of two binomials or sometimes two larger polynomials. So let's go ahead and we'll try to implement a grouping strategy. So in this first question, we're told to factor completely. Now, the first thing that I'm always going to try to do is I'm always going to try to look for common factors. So in the first question, I have a times x plus y minus 3b times x plus y. So notice that between these two terms, I actually have a common factor of x plus y. Since x plus y is a common factor, I can rewrite this as, I can common factor x plus y out, and rewrite this as x plus y times a minus 3b, where all that I've done is I've common factored out a x plus y, and that's fully factored. So here I didn't even need to group any terms because x plus y was just a common factor. In the next example, I have four terms. I have x squared minus xy plus xz minus yz, and there's no like terms to combine. So I might want to try to implement a grouping strategy. So when you're implementing a grouping strategy, all that you're going to do is you're going to take two terms, and the first two terms, and you're going to common factor, or you're going to find any common factors in the first two terms, and then you're going to do the same thing in the second two, for the last two terms. So there's a common factor of x between the first two terms. So I'm going to go ahead and I'm going to factor out x. And if I do that, I get x times x minus y. So x times x minus y. All that I did was I divided this first term by x, and then I divided the second term by x. Plus, well, these last two terms have a common factor of z. So I'll just common factor out z. And I get z times x minus y, because xz divided by z is just x. Yz divided by z is just, or negative yz divided by z is just negative y. So now that I've gotten this polynomial written in this semi-factored form, I've started to group here. You might notice that I have another common factor of x minus y between these two terms. So I can common factor out x minus y, and I get x minus y times x plus z. Whoops, x plus z. So all that I did was I just common factored out x minus y out of these two terms that I've created. And now this is fully factored. I have in factored form x minus y times x plus z. So moving on to the next example, we have in question 3, a squared plus b minus ab minus a. So since there's 4 terms again, and there's no common factors between these 4 terms, I'm going to employ a grouping strategy. So remember that when you employ a grouping strategy, you're looking for common factors between two terms, between 2 terms, groups of terms. So the first 2 terms are a squared plus b, which don't have a common factor, minus ab minus a. So the last 2 terms have a common factor, but the first 2 terms don't have a common factor. So I can just rewrite the order of that I've gotten these terms written in, and I can rewrite this as a squared minus ab minus a plus b. Now if I group the first 2 terms and I common factor the first 2 terms, I get a times bracket a minus b. In the next 2 terms, I've got minus a plus b, which don't have a common factor, but I can kind of see that minus a plus b looks similar to a minus b. If I common factor out -1 out of minus a plus b, I get a minus b. So I can rewrite this as minus bracket a minus b. Now when I distribute this negative into the brackets, I get minus a plus b. So I haven't changed the value of this expression. I've just rewritten it in a different form. And now I've got a common factor of a minus b here. And there's actually, you can actually think about there being a coefficient of -1 here if you want. But the convention isn't to write -1 here. So it would be bad math form to write -1 here. So we'll go ahead next and common factor out a minus b to get a minus b times a minus 1. So all that I did was I common factored out a minus b between these 2 terms. And I'm left with a minus b times a minus 1. And now that's fully factored. So moving on to our last example, we have 4ax minus 4bx minus 2ay plus 2by. So the first thing to always do anytime that you're trying to factor that's going to make your life a lot easier is to look for common factors. Between these 4 terms, there's a common factor of, well, let's see, 4, -4, -2, and +2 are all divisible by 2. So the first thing that you should do is common factor +2 out of this polynomial. So let's factor that out. Well, if you divide 4ax by 2, you get 2ax. -4bx divided by 2 is minus 2bx. And minus 2ay divided by 2 is minus ay. And positive 2by divided by 2 is positive by. So next, let's try to implement a grouping strategy because we have 4 terms here. So our first 2 terms have a common factor of 2x. So let's go ahead and factor that out. So I have 2x times a minus b. Our last 2 terms have a common factor of y, and since this term has a coefficient that's negative, I'm just going to factor out negative y. So I have negative y times a minus b, because when you divide negative ay by negative y, you're left with a, and when you divide positive by by negative y, you're left with negative b. Well, now notice that I have a common factor here. of a minus b. So I can common factor that out. And I get 2 times a minus b, which was our common factor, times 2x minus y. So this factors to 2 times a minus b times 2x minus y. That concludes this video, and we'll see you in the next lesson.